New measurements show dark energy may be evolving. Japan is joining Artemis with a pressurized lunar rover. Why the moon has two different faces, and my experience with the total solar eclipse. All this and more in this week's Space Bites. Astronomers first measured dark energy in 1998. They were trying to measure the expansion rate of the universe, try to figure out whether the universe is going to slow down and stop, or whether it's going to slow down over an infinite amount of time, or whether it's even going to contract back in on itself, leading to the big crunch. But they were surprised to discover that in fact the expansion of the universe is accelerating, that there is some kind of energy that is pushing outward, that is intrinsic to the nature of space itself. The more space you get, the more of this energy that you get that makes everything accelerate faster and faster. One of the long-standing questions that astronomers had is dark energy constant over time? So if you've got this cubic meter of space and you've got this dark energy that is pushing outward within this cubic meter, was there more dark energy at the beginning of the universe, or will there be less in the future or more in the future? And one of the unsettling ideas is that if dark energy is changing over time, then maybe we could get to this thing called the Big Rip, where just the expansion rate of the universe gets faster and faster, that in fact it starts to tear galaxies apart, tears solar systems apart, tears planets apart, eventually even tears black holes apart. And so this is an important thing to discover. And right now, astronomers still don't really know how this is going to play out. But one really important survey was started about a year ago. It's called the Dark Energy Survey Instrument, or DESI. It's taking a large-scale survey of the cosmos. Every 20 minutes, it takes another image containing 5,000 galaxies and quasars, and then moves on and on. It just keeps mapping the sky. And it's mapping out the universe in 3 dimensions back to about 11 billion years ago. So all of the light that's been traveling towards us for 11 billion years. Now, for the closer areas, it's seeing a lot of galaxies, but after a while, the galaxies are just too faint. And so all it can see are the quasars, which are of course these actively feeding supermassive black holes. So the plan is that DESI is going to carry on this mapping operation for 5 years, but we just reached the 1-year anniversary of the instrument. And so astronomers released some preliminary results so that scientists can start to work with what they've already found. And it is just an incredible survey of the universe, building this 3-dimensional map. And one really interesting finding is that they were able to start to map out the large-scale structure of the universe and see the echoes of the Big Bang. So back in the cosmic microwave background radiation, there were overdensities and underdensities. And these have been places which were sort of dense amounts of gas in the early universe, but then those densities were maintained forward through the universe. And so then this turned into more stars, and then eventually turned into galaxies, and eventually turned into clusters of galaxies. The term for this is the baryonic acoustic oscillations. And so it's incredible that you can see just these changes in density at the beginning of the universe just continued on through the entire universe. And now when we see the large scale structures of the universe, we are seeing what were once these tiny over and under densities in the earliest times of the universe. But one of the other findings, and this is very tentative, so we're still going to have to wait for the full 5 years to get the answer, but astronomers think they're seeing some variation, some evolution in dark energy over the history of the universe. This is really important. This would help explain, are we going to lead to a big rip in the future? And also, can this help explain the Hubble tension, this difference in the expansion rate of the universe as measured in the cosmic microwave background? And now that if in fact dark energy is changing over time, that might explain why we see these different speeds for the expansion of the universe at different times. Even accounting for dark energy, if dark energy is changing, then that provides an explanation for what's going on here. So very preliminary results, not enough sigma to go deep on this yet, but it's a really interesting glimpse into what's coming down the road. The Japanese are joining Artemis with a pressurized rover. Now, last week I talked about how NASA is planning to build an unpressurized lunar rover, and they've chosen 3 different companies. Was it last week? Was it 2 weeks ago? Yeah, okay, all right. They've put out a contract to 3 different companies to design preliminary lunar rovers, and then NASA will pick the one they like the best and have them further develop it. And these are unpressurized, so the astronauts will have to wear their spacesuits and they'll get into the rover. The vehicle can follow them around and even do exploration on its own. But this week, we learned that the Japanese Space Agency is going to be joining NASA for the Artemis missions, and they're going to be providing a pressurized lunar rover. And this thing is going to be pretty amazing. The plan is that it will allow 2 astronauts to be inside the rover, and then they don't have to wear their spacesuit. They can wear their shirt sleeves. And it should be capable of keeping them alive on the surface of the moon for 30 days. And so they can go on some extended mission around on the surface of the moon, exploring the South Pole, get in and out of the rover into their spacesuits, do work, come back into the rover, live, sleep, eat inside the rover, and then just keep doing their work, and then eventually return to either the human landing system or eventually some future lunar base. And the rover is designed to last for 10 years, so it's going to go on many, many missions. The plan is for the rover to be part of Artemis 7. And did you know that NASA was planning out all the way to Artemis 7 so far? But we don't know the launch date for this mission, but it'll be in the early 2030s. And as part of this announcement, NASA also said that a Japanese astronaut is going to join them for one of those future Artemis missions. And so this Japanese citizen, whoever they are, is going to become the first non-American to set foot on the moon. Now, I'm going to talk some more about the Japanese Space Agency at the end of this episode, so stick around for that. Why the moon has 2 different halves. Now, we only see the near side of the moon, and when we look at the moon, it looks relatively smooth, and you can see these darker regions. These are called the mare, and they're the results of ancient volcanic lava flow across the surface of the moon. And when the Apollo astronauts went to the moon, they were able to collect up samples from the moon and bring them home, and they found that those samples were rich in titanium oxide. Now, we can't see the far side of the moon, but spacecraft can orbit the moon, and they have shown that, in fact, the far side of the moon looks dramatically different from the near side of the moon. You don't have those giant volcanic mare. You instead just have crater after crater after crater. The entire far side was just pummeled by space rocks. Why are the 2 sides different? A little over 10 years ago, NASA sent a mission to the moon called GRAIL, and its job was to measure the gravity of the moon, to determine the shape of the gravity field of the moon. And one of the things that they found was that this gravity field is lopsided, that it is more massive and dense on the side of the moon that's facing away from the Earth. And so, what's going on? Why are the 2 sides of the moon so different? They found that this titanium oxide is part of the volcanic activity on the near side of the moon, and that you shouldn't get those elements in such abundance on the near side of the moon, that they should have fallen and sunk down into the moon early on in its history. But some process caused it to upwell again up to the surface of the moon. And so it really looks like the crust on the near side of the moon is a lot thinner than it is on the far side of the moon. And so you got that volcanism and you got these heavier elements appearing. How did the crust get so different on 2 sides of the moon? That is still an open question. But we actually reported that there was a reheating event. So I wonder if that's all related. Okay, testing a probe to drill into an ice world. We're fascinated by the ice worlds here in the solar system. We've got oceans of liquid water. The only problem is that they are shielded underneath a thick shell of ice. So the question is, how do you get down through that ice and sample the water and find the European space whales? The best system that people have come up with so far is a melt probe. So you take a nuclear reactor or a radioisotope thermoelectric generator, the kind of thing that powers Curiosity and Perseverance. It's very hot. And then you put it at the front end of a dart. It melts its way down through the ice shell on Europa, and the meltwater collects behind it and freezes as it continues to go down through the ice. But now researchers have proposed an additional modification to the system. The prototype drill is called the Search for Life using Submersible Head, or SLUSH, another backronym. And so in addition to the melting system, it also has a drill bit on the front of the probe. So the drill bit churns up the ice in front, and then the heat channels the water back behind the probe so that it can then continue to descend down closer and closer to get to the water underneath. They tested the slush probe in an ice tower in their facility, but they've actually taken this to Devon Island, which is a place that's often used to recreate Mars missions. And they were able to get it to go down into the ice a couple of meters. But the plan is hopefully to get it to go down to about 100 meters and demonstrate that this technology works. And then if you can go 100 meters, then maybe in the future it can go 50 plus kilometers down through the ice to get to the European space whales. Every week, we do a vote on our channel where you tell us what you thought was the best news story of the week. And the winner this week was Vera Rubin's camera is ready. And I 100% agree with you. Why is this not 100%? Now, we put the vote onto our channel every week within about 24 hours of when we post Space Bites. So if you're just scrolling on YouTube, you should see it. Quickly vote. You can go to the community tab to find it. But the best chance is make sure you're subscribed to the channel and click on the notifications bell. An atmospheric rainbow on an exoplanet. Now, have you ever seen a rainbow around the sun or the moon? They're called sundogs or moondogs, and they are caused by ice crystals in the high atmosphere. And then sunlight is coming through the ice crystals and produces this amazing halo around the sun. And then there's another kind of atmospheric effect called the glory. And this is similar to a rainbow. So you think about the way we see a rainbow, we are seeing sunlight that is reflecting off the inside of water droplets and coming back to us. With a glory, you're actually getting an effect that comes from the wave interference of light. And you can get this rainbow-like pattern that appears in the sky. We see them on Earth, we've seen them at Venus, and now astronomers think they've seen it on an exoplanet for the first time. The observations were made with the European Space Agency's Cheops mission, which is characterizing known exoplanets, trying to understand their orbits, their radius, learn a lot more about these existing planets that we already know about. So astronomers were watching this exoplanet WASP 76b as it was transiting around its star for several years, and they watched each of those transits. And what they found was that there was this strange brightening that was happening just between the day side and the night side, which is called the terminator of a planet. And they propose that we're seeing one of these atmospheric glories, this weird rainbow on the surface of the exoplanet sort of nicely matches the geometry of the light from the star reaching and then coming towards us. Now, this is not an Earth-like world. The temperature of the cloud tops are 2,500 Kelvin, so not habitable. And yet, it's kind of amazing that we can see these familiar features in the atmosphere of a completely alien planet. A neutron star collided with a light black hole. Now, we have learned about dozens of collisions between black holes in gravitational waves, and this is thanks to LIGO. And now we're on the fourth observing run of LIGO. They've upgraded all the instruments, they've upgraded the Virgo detector as well, and now they've added the Kagra detector. So now you've got these three different gravitational wave observatories working together to image the sky in gravitational waves. And they're finding several black hole collisions every week now. But recently, astronomers detected something really weird. It seems like it is a neutron star with about 1.2 times the mass of the sun colliding with an extremely light black hole, something with, say, 2.5 to 4.5 solar masses. So this is an incredibly rare event, and to be able to get this neutron star colliding with such a low mass black hole, this is brand new territory, and yet this is the capability of the increased, enhanced LIGO and the other gravitational wave observatories. The 2024 solar eclipse. Now, I mentioned last week that I was on my way to go see the 2024 solar eclipse in Dallas, Texas, and the weather forecast looked terrible. There was going to be thunderstorms on the day of the eclipse, cloud cover, and it didn't look good, but I was locked in. Had to attend a family event, so I had to go. Well, we got really lucky. The weather forecast just kept getting better and better, and on the actual time, the forecast said that the thunderstorms weren't going to show up until about 8 o'clock at night, while the total solar eclipse was happening around 2 o'clock. And so still there's a lot of clouds in the sky. It rained a bit, but we went to the place we were going to be watching the eclipse from. And about 30 minutes before, the clouds parted, and it was just perfect for the entire time. And my wife said, you were just staring at the eclipse for the entire totality. And it's true. I just, like, as soon as the last little bit of sunlight was gone, I was just watching the eclipse dumbfounded. It was amazing. And it's funny because I was telling people sort of what to prepare for and what an incredible event it was. And afterwards they're like, okay, I get it now. How do I see more of them? So many new people are going to become eclipse chasers. So I want to give you some suggestions on what's coming up next. In August 2026, there's going to be an eclipse that starts in Greenland, goes through Iceland, and then goes across the North Atlantic, and then goes through Portugal and Spain. That sounds great, to be in Iceland to watch an eclipse. That sounds good. And then in 2027, there's going to be an eclipse that goes right across North Africa. So think about Morocco, across to Egypt. And then in 2028, there's going to be an eclipse in Australia. So there you go. You've got 3 upcoming eclipses to plan your future travels around. Now here is a quick series of images of the eclipse seen from space from one of the GOES satellites. And so, when we see the eclipse, we see the moon pass directly in front of the sun, but from space, you see the shadow of the moon move across the Earth, and it's such a cool image. Now I want to share a couple of videos with you. First, here's a video from the European Space Agency of a reaction wheel that is tumbling and re-entering the Earth's atmosphere. Now, it's not actually re-entering the Earth's atmosphere. This is a simulation. They built a special chamber where they fired heated gases at this reaction wheel at several kilometers per second, simulating what it's like for a spacecraft to come back out of orbit. And the reaction wheels, these are these big spinning wheels that allow the spacecraft to change its direction in space. They're the heaviest, densest parts of the spacecraft, and they're what often survive through atmospheric reentry. And so the question is, can you build a reaction wheel that tears itself apart as it's entering the Earth's atmosphere so that it doesn't survive that journey and it doesn't cause a risk to anybody down on Earth? So they took this reaction wheel, put it in this chamber, made it tumble, and then watched as the heated gases blasted it apart. And then the next video was recently shared by SpaceX. It's one of their Raptor engines. This is one of the ones that's configured for vacuum, and so it has the much larger bell. And so near the middle of the video, as this engine is starting to shut down, you see these rings start to appear in the middle. It's a very cool effect. And these tests are really important because with the vacuum engines, when you think about how they're going to have to be able to turn them off and on to make changes in orbit, to be able to land on the surface of the moon. So a lot of tests still need to be done with the vacuum engine. And so it's great to see them sharing these with us. Every week I write an email newsletter, which I send out to, 70,000 of my closest friends. Now I write every single word in the newsletter. There are no ads. It's completely free. And we cover 30 to 40 stories on Universe Today, and we talk about those in the newsletter. And so I want to just show you a few of the interesting stories that didn't even make the cut for Space Bites. For example, does artificial intelligence explain the great silence in the universe? How much of Venus's atmosphere is coming from volcanoes? And the 7 most interesting worlds to search for advanced civilizations in the cosmos. So you can sign up to my weekly email newsletter. Just go to universetoday.com/newsletter. All right, I'm going to talk about JAXA some more, the Japanese Space Agency. But first, I'd like to thank our patrons. A special thanks to Abe Kingston, Andrew Gross, Antonio Lofi-Lara, David Giltinan, Dennis Alberti, Dougie Stewart, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Mark Anstis, Modso, Paul Rohrbach, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. Earlier on in this episode, I talked about how JAXA, the Japanese Space Agency, is supplying a pressurized lunar rover for an upcoming Artemis mission, one that will allow astronauts to explore the moon for 30 days. And this just reminds me how much I love JAXA. I'm such a big fan of the Japanese Space Agency. We saw with the Hayabusa 1 mission how they were able to retrieve a sample from an asteroid after it seemed like everything had failed on the mission. They were still able to get home and deliver just a few micrograms of asteroid to Earth. With Hayabusa 2, they nailed it and were able to bring much more of a sample home. They dropped several rovers, hoppers onto the surface of asteroid Ryugu. They shot it with an anti-tank weapon to sort of see what was underneath the surface of the regolith. Really interesting, innovative ideas. And I think I'm most excited about the upcoming Mars Moons exploration mission. This is the spacecraft that's going to launch in 2026, and it's going to fly to Phobos and retrieve a sample of Phobos and bring it back home to Earth. And you can't just go into orbit around Phobos because it's so close to Mars. It's really tricky. So you have to do a orbit that brings you closer and farther away from Phobos, but you're still sort of orbiting around Mars. And so they're going to make several attempts. They might collect one sample. They might collect 2 samples from the surface of Phobos. They're going to be equipped with an 8K camera that is going to be recording video and images of the surface of Phobos. And then on a regular basis, they're going to send images home. They've partnered with the National Broadcasting Service of Japan, NHK, to produce this camera. And so, people always ask, like, why can't we see some 4K, 8K images coming from other places? And, it's hard that you need bandwidth to be able to send video back home, but we could get regular images coming from Phobos. It's also going to carry a German French-built rover to Phobos. It's going to deploy this rover onto the surface of the moon, so it will be able to continue exploring on its own as well. So there are so many cool, innovative ideas that come out of the Japanese Space Agency, and I really feel like they strike this balance between carrying out missions, but also being willing to experiment and test out new ideas and push the boundaries with their missions. And this is just, I could talk about all kinds of, they had the first interplanetary solar sail. They went and studied the atmosphere of Venus. There's a ton of really cool missions. So congratulations to everyone at the Japanese Space Agency for what's happening with the Artemis missions, as well as the Phobos mission, as well as all the other cool stuff that's in the pipeline. I hope you'll become a fan of JAXA's work as much as I am. All right, that's it for this week. We'll see you next week.